In this section 8.2, we're going to have a look at those sources or other sources of infection that are not bacteria. Bacteria can be treated with antibiotics. This is not so with a virus. The virus is probably the most common type of infection other than bacteria that infects us. Often flus and whatnot come around annually, and people get a shot to, especially older people, get a shot to prevent them from getting a virus. Now I want you to pay attention to this particular virus, this photo 8.21 of the virus here, because when we look at viruses in the next section, we will see the structure of the coronavirus, which is very interesting, and you can see how the little yellow ball, basically with those little blue parts that are on top of it. The structure will be interesting to see how it goes. We'll see that when we look at the coronavirus. Now, viruses are a source of infection, and they are a pathogen, but the pathogen, unlike or sort of like a bacterial one, the virus pathogen is only tiny, only very tiny. When it's looking for a host cell, and when it comes in, the host cell is damaged or destroyed. Right? So we have to remember that viruses cause many of the most common diseases. Colds and flu, which is influenza with flu. They also cause measles, mumps, rubella, polio, chickenpox, and cold sores, also known as herpes. There are over 200 different viruses causing colds, and many of us throughout our time get a cold. It goes after a little while and then we forget about it. One interesting thing here that we need to be aware of, and it will become very obvious when we think about the coronavirus, the droplets in a sneeze travel out of your mouth at over 160 kilometers an hour. 160 k's an hour. So you can see that they are coming out with quite force, and they are going to travel a fair distance, and hence you be finding that catching a cold is pretty easy to do when you understand that. In figure 8.22, you can see how the coughing and sneezing puts droplets and whatnot into the air and how far they go. So if you're traveling at 160 k's coming out of your mouth from a violent sneeze or a cough, you can see that over the years why people have said cover your mouth when you cough or when you sneeze. Sneeze into your sleeve or cough into your sleeve, as you've been told. Remembering this was written years before the coronavirus. So there are colds. Although colds are difficult to avoid, you can reduce your chances following: covering your mouth, washing your hands frequently, not sharing personal items, avoiding close contact, in other words, social distancing, staying at home if you are sick so that you do not infect other people. These have been known for years and fairly standard, but they have become very prevalent now with the onset of the coronavirus. The cold virus attacks the lining of the nose and throat. Extra mucus is produced so that your nose is running. It becomes blocked, making it difficult to breathe. We know that when we blow our nose or when we sniff and whatever else, and the stuff that we're sniffing and blowing out is in fact the bad pathogens that were in there. Take a close look again at these figures here, and we are going to compare them with in the next video when we have a look at the coronavirus. This is an artist's impression of viruses that cause the flu. The symptoms of the disease are high temperature and aching muscles. So we can look at these ones here and see that what we're doing now has been fairly standard. We just need to be more aware of it. In the battle against viruses, antibiotics don't work because, as we saw, they work on bacteria, right? So bacteria will come in and cause a secondary infection only because the virus has caused your immune system to develop or weaken, and then it makes it vulnerable to secondary or bacterial infections. We do have an immune system that helps us to battle against viruses, but there is one problem, is that they mutate fairly easily, and the body needs to be constantly going against them. Viruses are difficult to treat as they do not show any signs of life outside a living cell. Antiviral drugs do not target viruses directly. They work by stopping the reproduction of viruses. This is achieved by stopping the viruses from entering the host cell or interfering with the virus once inside the host cell. Great care must be taken not to damage the host cell and other cells of an infected person. This is why, under the current environment, if you are suffering from comorbidities or other conditions, this is why the viruses can be so damaging and also deadly. Stop and think for a second about the size of viruses. One promising area of treating viral disease is nanomedicine. Nanotechnology. Well, what is a nanometer? It's 1/1000th of a meter. Or pick up a ruler and have a look at it and see how long a millimeter is, and then try to imagine it 1/100000th of a millimeter. That is a tiny, almost impossible for the human mind to understand that sort of distance. But medicine is working in nanotraps to try and stop the body or stop the viruses from getting inside and helping with the body's immune system. As we see here, when European settlers first came, they brought measles with them. The Aboriginal population had no immunity against that, and they were quite susceptible to it. Obviously, since 1966, people have been immunized against them, so not so bad. Chickenpox is another virus that causes some rather horrible conditions, and you can see here in figure 8.25, see the chickenpox which is on this young person there. Now, what has been discovered is that sometimes infections can come back later in life, and when chickenpox comes back later in life to older people, it comes back in what is called shingles, and this is on the inside under a person's arm here, around towards their breast to the front there. You can see the similarity between shingles and chickenpox, right? The virus has become active again. Now, routine immunisation against chickenpox did not start until 2006, so you are all immunised against it. I wasn't immunised against it when I was young, and hence I did get chickenpox when I was young. All right, other parasitic ones, right? Now, we know from our Year 7 science that a parasite just lives off the host, doesn't do anything for the host, destroys the host eventually. And one of those is malaria. Now, you can see the tropics in between the top of Australia and the tropic and the equator, Tropic of Cancer and the equator. You can see that yellow area where the malaria is rampant. When I walked the Kokoda track in 2008, a fortnight beforehand, And the whole time, the whole fortnight I was there, and then a fortnight after I came back, I had to have my malaria medication. I had to take the whole lot. I was fortunate I did not get bitten by a mosquito and I didn't get it. But malaria is rampant in these areas, and the World Health Organization, the United Nations, is trying to wipe out malaria. It is strong in those areas. It's an interesting side note is that one of the drugs to treat malaria could possibly be, and it's controversial, but hydroxychloroquine could possibly have some results against the coronavirus, but that does remain to be seen. Malaria, which is spread by mosquitoes, is another one. So, of course, trying to prevent mosquito bites, right, is also a way to try and control it. Another way that we get infection is from lack of running water. You'll notice here that there is still or stationary water. One of the health benefits of Western civilization, our modern civilization, is running water. So we do not get bugs in the water, plus we have additives added to it to help with that. But there is much more chance of getting a dysentery type disease, amoebic dysentery, if you do not have running water. Do not have running water is another type. Fungi is another one. The job of fungi, you would know from Year 7 science, is to convert organisms back into the soil. Okay, and can also be, their job is to decompose or mold and put them back into the soil. But if we breathe in these spores, then we can get a disease. Right? Spores, they travel through the air. Another source of infection is tinea, which is a fungal type growth. Any of us who've been on a school camp or to camps or scouts or various places, go into the army or whatnot, they will recommend that you shower with thongs on, with a pair of thongs on your feet, because tinea lives in moist, wet conditions, and this is the sort of thing it does to you. Tinea, it's an infection between the toes, sometimes called ringworm because of the shape of the inflamed area. And we do, especially when on camps, we take precautions to make sure that we don't get tinea. So you can see there are other sources of infection than just bacteria, and they are very, very common. They can be range from just being mild cold through to an influenza that could have you sick for 2 to 3 weeks and lay you in bed. So we do have to take care against those other sources of infection. And in the next video, we'll have a look at the current one, the once in a 100-year virus,